Here we're going to look at some of the different properties of integers. Positive and negative. One thing that needs to be clarified is that 0 is neither positive nor negative. So we don't really refer to it as either negative or positive. Now, positive and negative integers, even and odd is something we understand quite well with positives. So even integers, for instance, 2, 4, 6, etc. Well, the pattern just continues if we go to the left. So 0 is an even integer, negative 2 is an even integer, negative 4 is an even integer. So all of these are even. So what about odd? Well, again, positive odd integers, pretty straightforward. 1, 3, 5, these are all odds. And again, the pattern just continues if we go to the left. Negative 1, negative 3, negative 5, etc. So it's pretty easy for the most part if you're looking at negatives. If you want to determine whether they're even or odd, just ask yourself, is the positive of that number even or odd? And then just remember that 0 is even because it is just simply 2 away from positive 2, which is an even number. Now, a slightly bigger topic here, the number of factors that a number has, a positive number has. 1 is a special number. It's called the identity, and it only has one factor. So just one factor itself. Now, let's take a look at some other numbers. Let's say like 2. How many factors does 2 have? Well, 2 has 2 factors, 1 times 2. What about 3? 3 also has 2 factors, 1 times 3. Or 5, 2 factors. Or 7, 2 factors. So if a number has 2 factors, that makes it a very special number in mathematics, and we call it a prime number. So those are the first 4 prime numbers. And the next ones are, so 2 is the only even prime number. Then we have 3, 5, 7. The next one would be 11. The next one is 13, 17, 19. It goes on forever. It's worth knowing certainly those. 2, 3, 5, 7, 11, 13, 17, and 19. And aside from 2, they're all odd. Now, what kind of numbers have more than 2 factors? Well, let's take a look at a number like 9, for instance. So 9, you can write 9 as 1 times 9, or you could write it as 3 times 3. Now the 3's there are the same, so this has only 3 factors. What about 16? Could write that as 1 times 16, or 2 times 8, or 4 times 4. Again, 1, 16, 2, 8, and 4. That has 5 factors. So this one has 3 factors. This one has 5 factors. Let's take a look at one more here. 25. 1 times 25, or 5 times 5. This one has 3 factors. So if it has an odd number of factors, then it's a square. 9 is 3 times 3. 16 is 4 times 4. 25 is 5 times 5. You're always going to see that one row there where you have the same factor multiplied by itself. So these are perfect squares. And what else is there? Well, let's take a look at a number like 15, for instance. 15, you can think of 15 as 1 times 15, or 3 times 5. So it has 4 factors. How about 28? 28, you can think of that as 1 times 28, 2 times 14, 4 times 7. It has 6 factors. So all of these have an even number of factors, and we don't really have any special name for that. If it has more than 2 factors, So 3 or more factors. Then we call it composite. So we have prime numbers and we have composite numbers. And of the composite numbers, perfect squares are kind of like a special case. All other composite numbers are going to have an even number of factors. Perfect squares have an odd number of factors. And then the only other number other than composites and primes is 1, and 1 only has one factor, and it's got a special name. It's called the identity.